Last question of the test. This is simplifying a radical. So hopefully by now you've got the hang of it, right? Break this down into prime numbers. 54, of course, is, what is it, class? 6 times 9, correctamundo. 6 would be 3 times 2. Those two are prime numbers. And 9 will be 3 times 3, prime and prime, okay? So in other words, I can rewrite this as 3 times 3 times 3 times 2, right? I can see that these are pairs. Don't forget the concept that the x squared and the square root and the square cancel each other out. They're inverses of each other, so it's like if the whole thing just disappeared, leaving you only the x, correct? And that's the reason why you want the squares. You want the square so that you can, right, this 2 right here is 3 squared. This 3 right here is by itself. This 2 right here is by itself, not a pair. But this one can cancel each other. So this whole thing is gone, leaving you only that number 3 outside. Okay? Same thing for the x's. You got 4 x's, right? So I can make x squared and another x squared. And the reason for that is I can cancel that radical. It's gone. The only thing I have is the x. Cancel that radical. It's gone. The only thing I have is the x. Same thing for the y's. There's 4 y's, right? So I can have a square right there and another square right there. That's y squared. Y squared cancels, y and y outside. The z is by itself, so guess what? It stays by itself on the inside. So in this case, the only thing that came out was a 3. There's 2 x's, that's x squared. There's 2 y's, that's y squared. The 3 and 2 stayed inside, so that's 3 times 2 is 6. And the z stayed inside, so that's a z on the inside. And that's the answer right there. You simplified the radical.